Again, welcome to today's webinar, Best Practices to Migrate Your Data Warehouse to Amazon Redshift. Our presenter today is Greg Kerala. Greg is a Senior Manager, Business Development for Database and Analytics at Amazon Web Services. He has over 15 years of in-depth experience in business intelligence and data warehousing at Oracle and Business Objects, now SAP. A former U.S. Army officer, Greg holds a master's degree in Information Systems Management from Carnegie Mellon University. Today with us, we also have Zach Christofferson and Eric Ferreira, who will be our webinar moderators and answering your questions throughout the presentation. Greg, welcome. The floor is now yours.
Great. Thanks, everyone. And I also wanted to quickly introduce three co-presenters I have with me. So David, Sharat, and Blagoy from TrueCar. And they will be presenting a case study in terms of their migration as we proceed through today's presentation. So just to quickly cover the agenda, I just wanted to start off by talking about the motivation for change in the migration. Just what are some reasons that customers look to migrate into Amazon Redshift. And then, of course, get into some discussion around patterns and best practices, a brief overview of the AWS Database Migration Service. And then I think, well, hopefully most interesting for everyone assembled this morning is to hear from an actual use case from a customer, TrueCar, on their best practices and lessons learned from their migration to Amazon Redshift. And then we'll have questions and answers at the end, but please, as the moderator mentioned, ask your questions through the question pod as we proceed through the material this morning. So first, this is meant as a best practices meeting is a little bit more advanced in terms of we assume that the basics in terms of understanding Amazon Redshift are at least known at a high level, but in case you're new to Redshift and to AWS webinars, Amazon Redshift is a relational data warehouse. Of course, we have tables, we have relationships between the data, and you can easily move from existing data warehouse platforms to Redshift, and we'll talk about best practices to do so today. But then importantly, Redshift itself is a column store, which means that it's organized for analytics at the physical data level. This allows me to, selectively prune queries based on the columns in the actual query itself, and can dramatically reduce the I/O and deliver faster performance for query response times for analytic queries. And then, of course, it's massively parallel and up to petabyte scale. So massively parallel means I could start a small cluster with 1 node, 2 nodes, 5 nodes, 50 nodes. So it allows me to spread the not only queries across multiple resources in the cluster, but also loading data in parallel as well. And I qualified by saying up to petabyte scale, and we'll discuss in a few slides here, but you could start as small as 160 gigabytes and then seamlessly grow to multiple petabytes of data. And we have many customers across the full range of data from less than 1 terabyte to multiple petabytes of data running in production Redshift clusters today. And then we think what's differentiating for Redshift is that it's a fully managed platform. And what this means is that common database administrator tasks that can include backups and patching and managing the infrastructure, those are all handled by the Amazon Redshift service itself. So we understand those are critical tasks that take a lot of time and resources on premise today, but this is essentially part of the Redshift service, and customers find a lot of value because now where database administrators or data analysts are concerned, they really just focus on delivering world-class analytics and not having to worry about the infrastructure to actually provide that capability. And then Redshift itself comes in two different variations. One is optimized for cost and storage, and that's our magnetic HDD-based platform. And one is optimized for high performance, and that's our SSD platform. And what's oftentimes customers find most interesting, at least initially, about Redshift is that it can deliver costs as low as $1,000 per terabyte per year, and you can start for as little as 25 cents per hour to understand if Redshift makes sense for your use case. And if you're more interested in kind of the basics of Amazon Redshift, we do have a number of resources on aws.amazon.com/redshift and other webinars that go into Redshift overview as well that you can find as follow-up resources to this webinar this morning. So the next point then is to think about why do customers consider migrating to Amazon Redshift. And I think oftentimes one of the first consideration is around performance. And so thinking about the day in the life of an analyst and sort of expectations that they can get answers to their questions very quickly. And here's just a few examples of customers that have successfully implemented Amazon Redshift and are seeing significantly faster performance at significantly reduced cost to their existing platforms. And so oftentimes if you have an on-premise data warehouse, maybe it's up for hardware renewal or requires significant patching, or you're leveraging a system like Apache Hadoop for query and analytics because of the cost that it delivered. We have many examples of customers that have tested Amazon Redshift and decided that for their SQL-based queries that Redshift delivers significantly better performance. And there's links in this to provide more details behind these case studies. They will provide as a follow-up to today's webinar as well. And so the next thing, thinking about moving beyond the incentive for performance, is really thinking about the cost of the data warehouse. So, in my experience, a typical data warehouse project typically would run in the tens of thousands, if not hundreds of thousands of dollars for a project. And of course, you have to pre-plan for capacity 2 or 3 years out, purchase the hardware for on-premise, or manage systems with significant costs. And what Redshift can deliver is significantly lower price and performance. And because we have two different options, both for the dense storage and dense compute, so one is magnetic and one is SSD, and we just want to provide some costing information. This is based on our U.S. East region. Of course, other region pricing may vary, and you can find full information on AWS at amazon.com/redshift and look for pricing for your individual region that you run in. And to understand your cost for Redshift is actually fairly straightforward. So just look at the type of node, whether it's dense storage or dense compute, the number of nodes in your cluster, and then you can a rough approximation in terms of the on-demand. And then given the nature of database workloads, we find that oftentimes they run 24/7. And so taking advantage of the discount structure through 1 or 3 year reservations oftentimes provides significant cost savings. And so in terms of motivation for change, this idea of delivering better performance or lowering costs significantly are the typical reasons that customers become initially interested in Amazon Redshift from a migration perspective. So if we kind of bought into the idea that we want to deliver faster performance at dramatically lower costs, let's think about some considerations before you actually embark on your migration project. And so this is really geared towards thinking about on-premise environments, but even if you're running a self-managed data warehouse on EC2 or another cloud platform, I think these lessons equally apply. So the first is, obviously, depending upon your experience with data warehousing, you probably have extensive extract, transform, and load processes, potentially tuning and coding that has went into your process. And so the temptation is to say, well, Amazon Redshift has a large and rich ecosystem of partners such as Informatica and Talend and SnapLogic, and if you happen to be using one of those, yes, there are some efficiencies of scale in terms of being able to reuse some of that work, or if not a majority of that work, but we really want to discourage the idea that I can take my knowledge of a previous data warehouse system, whether it's the common vendors that we all hear about in the marketplace, and just assume that Redshift works the same way. So yes, Redshift is a managed platform, but you still have to consider that it is a database that has some unique characteristics and make sure we can optimize for those. But then more importantly, what we find is that oftentimes if you have a data warehouse that's been developed over a number of years, you might have built something into this processing 5 years back, 6 years back, maybe longer, that maybe doesn't really apply to the business anymore. And I think this is the most critical question, is to think about, what do I really want to do and what do I need to do? So this is just the idea that, thinking about migration and adopting a new data warehouse platform, if I believe in the cost and performance benefits of Redshift, provides you some time to reconsider decisions potentially that you made a number of years back. And so one common pattern here is that, you might be using your data warehouse or existing platform to do a lot of transformations directly in the database. And of course, Redshift could support that workload as well. But there could be alternative patterns that might be more cost effective. For instance, to remove the transformation processing to a third-party partner tool or through Apache Hadoop might provide better, more scalable alternatives. And this is a great chance to reconsider some of those decisions that were made in the past. And then, of course, the other piece that comes to it in terms of just moving as-is workloads is that the breadth and depth of new data sources that might be outside of the data warehouse or might be coming from systems that don't necessarily or easily represent themselves as into a relational schema, but nonetheless, the data is valuable to be able to be combined with our data in our data warehouse. And so a very common pattern here is to use Amazon Elastic MapReduce, or EMR, or Apache Hadoop, your Hadoop distribution of choice. And essentially, this allows you to run Hadoop jobs, whether it's MapReduce or Spark or some of the different patterns such as Pig, to be able to transform the data in Hadoop, impose structure on it, and then load the data into Redshift. And so particularly we see with customers is that the cost and performance of Redshift can be very compelling and allows you to add more data into your cluster than high-cost on-premise data warehouse appliances provide. And so the opportunity to add more data than into your warehouse to augment and enrich the data becomes very appealing. And oftentimes customers will use Apache Hadoop or Amazon EMR to be able to impose structure on that data. And we'll talk about some patterns and best practices to do that in subsequent slides. So just quickly to think about the architecture of Redshift, and I want to cover this just because it's really important to think about migration, is to understand a little bit about where you're migrating into. And so from a leader node perspective is really something you don't pay for. It's essentially transparent, but provides the endpoint for SQL queries. And what's nice from a migration perspective is that this leader node presents itself through JDBC or ODBC as a Postgres database. And so you are able to use open source Postgres ODBC, JDBC drivers. We do have Redshift optimized ODBC and JDBC drivers you can use as well. But from a business intelligence tools perspective, if your end users are familiar with common tools like Tableau or MicroStrategy or Looker, full rich set of BI partners that actually natively connect to Redshift. But simplistically, if your BI tool supports Postgres database, we expect it would fully work with Redshift today, and this is really based on our exposure of Amazon Redshift as a Postgres data source. And then the leader node, of course, is very lightweight. Essentially, contains the optimization plan. It coordinates query execution across n number of nodes in my cluster. And then the compute nodes themselves actually are the combination of direct attached storage plus the CPU cores for processing of data, which provides very fast performance by combining the data in disk and not having to go over an interconnect between compute and storage. And as I mentioned, the compute nodes itself, the data is organized by columns, and there's tremendous amount of benefits by taking advantage of columnar compression, reducing I/O by query pruning just the columns that are part of the actual query, which delivers really super fast performance for a majority of workloads. And of course, the fact that Redshift is a massively parallel processing system allows me to query and distribute that query across n number of nodes in the cluster. And then from a backup perspective, backups are actually stored to Amazon S3. Backups are continuous and automatic, and allows you to dynamically rescale or resize your cluster based upon additional requirements or additional data loads without having to pre-plan or pre-purchase expensive hardware to be able to anticipate future growth. You can just use the number of nodes that are required today and then seamlessly grow as your requirements expand. So let's just take a little bit deeper look at that architecture. And again, if you're interested in more of the basics of Amazon Redshift, we have other material. But today we want to look at some best practices for migration. But before we get into some of the migration best practices, just taking one step lower of a compute node, it's important to understand the concept of a slice. And so essentially, a slice is a segmentation of compute cores, memory, and disk. And of course, Redshift comes in dense compute, which that disk is SSD, and dense storage, that's a magnetic drive, depending upon if you're going to optimize for cost or performance. And so kind of understanding the number of slices based upon the node type becomes important from data loading perspective and essentially from a migration perspective. And I'll talk a little bit about that in a few slides here, the next few slides. But thinking about the architecture for Redshift becomes an important consideration for migration. And so if I think about a migration overview, and of course I'm going to dive a little bit deeper on these slides, but maybe if I were to recap my part of this presentation in one single view, I would think about the idea of a source database, right? This could be your on-premise data warehouse. It could be a database running on EC2. And a simplistic way to think about the migration is first we need to take all of our existing data and load it into the Redshift warehouse, right? This could initially be done for testing purposes, but then subsequently to bring up the initial loading of the data. And so depending upon the size of your data warehouse, your on-premise database, there's a couple of different options. Many customers will have a direct connection, AWS Direct Connect, which is either a 1 or 10 gigabit dedicated connection to be able to provide high throughput into an AWS region to actually move those files, those existing database files. I could use a VPN connection, multi-part upload, and then for larger databases into the tens, if not hundreds of terabytes and beyond, you could look at Amazon Snowball, which is essentially a device that we deliver that can have up to 80 terabytes of storage that can connect directly to your network, and you could use UPS or shipping this data directly into Amazon S3 and then load it from there. And so, depending upon the database that you're on today, there's many different tools to be able to extract that database as a CSV file. Of course, you want to compress it and then upload it at least for that initial copy of the data. Other ways to look at that would be by, if I have a data volume, let's say on EBS, being able, Elastic Block Store on Amazon within a particular region, I could essentially copy that data to S3 as well to load into Redshift. And then there are other options, which I'll go into around database migration service to be able to help with change data capture, Amazon Kinesis for streaming data capture, as well as using Apache Hadoop or Amazon Elastic MapReduce to be able to load the data as well. So I'll go into each of these, but just in terms of a quick overview of the ways we think about migration, I think this provides a great recap and summary. So thinking about moving the files to S3, and so as I mentioned, we'll oftentimes start with an initial data load, and so we want to extract the data from our existing platform, and then load that into S3, and then make sure that I can split that file into multiple, single file into multiple files to be able to get high-speed loading into Redshift. And so the way that I deliver these initial files, I mentioned, could either be through Direct Connect, through VPN, or by leveraging Amazon Snowball, depending upon the data volume and size. But then importantly, this essentially gets the data into the bulk data into S3, which then provides easy loading into Redshift. And I'll talk about some patterns to be able to get changes and keep the databases in sync here in a moment. But thinking about that initial upload oftentimes becomes a key consideration for our migration and actually provides a great way to be able to test Redshift for initial proof of concept type environments as well. And so I mentioned the importance of taking these files into single files into multiple copies. And this is really where we tie back to the concept of slices within the Redshift cluster. So if I were to use the anti-pattern, or what we would not recommend to do, you can think about one single file loading into a dense storage 2 8XL would essentially only be able to get 6.25 megabits per second, right? Because I'm only loading this single file, regardless of its size, into a single slice in my into my Redshift cluster itself. And so oftentimes when customers come to us and they have difficulties or challenges with data loading, this is one of the first things that we ask them to look at, is making sure that I have multiple files to load into my cluster. And if I look at the comparison, here's where I actually have 16 slices in my dense storage 2.8XL, so at least would have 16 input files, and now I can get 100 megabits per second per node and scale linearly as I add nodes. And so from a sizing of my cluster perspective, of course I want to think about the basic data size after compression, and maybe use that as a starting point, but for high-speed loading, I perhaps might add additional nodes into my cluster to be able to have that parallelization of the data load. And this all helps for that initial case of being able to not only get the initial data up, but there are cases where files are delivered to S3 and then loaded into Redshift for kind of a continuous data processing framework. And this provides a lot of utility for customers to be able to easily load data into their cluster. And of course, as I get into multiple files, I want to be able to understand the concept of a manifest file. And so a manifest file will simply provide a list of files and making sure they all get loaded. It's a JSON formatted text file, and it actually allows me control to make sure that if I particularly have multiple files, that they either all get loaded or none get loaded. And so understanding the concept of a manifest file is key to taking advantage of the parallelization of loading of multiple files. And then, one of the most simplistic ways to think about getting data into Redshift then would be through the copy command. And the copy command allows you to, essentially the native loading command for Redshift. Data files can either be in S3 or DynamoDB. It has a pretty simplistic format in terms of just the table name, the source, the data source, as well as the credentials, with different optional parameters, and being able to understand the copy command and its utility really provides great ways to be able to load data from your existing system into Redshift, assuming the files have been loaded into S3. Of course, as I mentioned, some non-structured or maybe data sources outside of just simplistic CSVs or gzip files. Of course, the copy command also lets you use JSON files. Excuse me. So the JSON file really goes through JSON paths, and I need to design a schema within Redshift to essentially be the target for these JSON files. But I can essentially provide SQL-based access into this information by leveraging the JSON path text file to parse the data and then loading that path expression into a column within the target table. Allows me to enrich my data or simply flatten my data into a relational structure for SQL-based BI tools to then be able to query. We also support the Avro format, so particularly from a migration perspective, we don't just think about migrating from existing data warehouses. Oftentimes, customers will migrate from Hadoop-based systems where they're looking to run SQL on Hadoop because maybe that provided a cost advantage or just a tool set they had, but they look at the price and performance of Amazon Redshift and essentially for SQL-based queries where I'm joining lots of data and find that Redshift can deliver significantly better performance. And so supporting some common formats like Avro becomes important, and leveraging the copy command with the Avro option allows you to parse the Avro data and load it directly into Redshift as well. So that kind of covers at least some of the basics of getting the initial data load as well as subsequent load. If the idea of extracting to a flat file, loading into S3, whether that file is CSV or JSON or Avro, and then loading it into the Redshift cluster. But the other way to think about rethinking our data warehouse and our analytic infrastructure is to consider beyond just files to stream data. And so this is really where Kinesis Firehose comes into play. And so Kinesis Firehose allows you to connect to a data stream. So here we're kind of showing a mobile device, but it could be a generic Internet of Things type application. It could be any kind of data source that generates a stream of data. And the nice thing about Firehose is that it has a simple toolkit to be able to connect to your existing device or devices, and then provide zero administration to then stream the data, order the data, and then drop the data into either S3 or directly into Redshift. It even now supports Amazon Elasticsearch as well. And so when I'm reconsidering my analytic framework as part of the migration, if real-time data or streaming collection of streaming data becomes important, many customers will now leverage Kinesis Firehose to be able to simplify the processing to get very high latent or low latency with very high data volumes into Redshift with simply essentially a serverless environment to be able to deliver that information. And so thinking about some best practices that I've discussed here, so leveraging the copy command, being able to compress your data into gzip or other formats to be able to minimize the amount of data that transfers and loads efficiently into the cluster, being able to use bulk insert operations, right? So using a start and end block and to be able to have multiple inserts as one single operation, and then leveraging Kinesis Firehose for streaming data are all best practices that our customers leverage with Redshift today. And then just going a little bit deeper, thinking about when I'm loading the data to understand that if I can sort the data before loading it, it can avoid the need to vacuum. And so vacuum essentially will remove unnecessary data blocks from the tables, and it can be a process-intensive operation. So if possible, I want to be able to avoid that by loading it in sort order. Another pattern is to be able to optimize my data as a series of time series tables. So essentially, if I have time-based data particularly, I can have different tables either by the day or by the month, and then essentially have a view on top of those different tables to be able to provide a single view across the full data set. And there's a couple advantages both from a sorting and vacuum perspective, but just from a maintenance perspective, it then allows a lot of flexibility to essentially have these time series tables to be able to deliver significantly better performance for larger data sets. And then, the important thing too, when I'm talking about, might seem like a little bit more of a discussion on data loading, but it's really critical for migration perspective, is to remember to run the analyze command whenever you've made any kind of changes to your data environment to make sure the database statistics are correct. So, beyond just thinking about multiple files, making sure statistics are updated becomes important for getting optimal performance in my cluster as well. And then, so they just kind of talked about some of the ways that best practices for actually leveraging the copy command and being able to load the data, but then leveraging Amazon Partner ETL really becomes a key component for our customers as well, where maybe they don't want to do or understand necessarily all the details around copy command, as simplistic as it might be. But this kind of comes from a set of partner tools like Informatica and Talend and SnapLogic and Attunity and a large list of others. And you can go to the Redshift partner page to be able to understand the full set of ETL tools. And so by adopting this Amazon Redshift platform, oftentimes not only from a data integration perspective, but also from a BI perspective, you can use the tools that your organization is most familiar with by leveraging the cost and performance of Amazon Redshift. And there's a number of free trials on the Amazon Marketplace, and there's more details on our partner page to get into that. So the next thing is just the last thing before we turn over to our friends at TrueCar to go through their use case is just a quick discussion around the AWS Database Migration Service. So many of the things that I've started off the discussion in terms of flat files and copy command and understanding its nuances do require a simplistic view, or at least a simple view of the API of Redshift to be able to leverage the copy command. And then the idea of using partner tools like Informatica can automate that. But even a different way to view it is to start leveraging the database migration service. And so it allows you to start your first migration in just a handful of minutes. Your application can actually continue to run during the migration. And you can not only move data into Amazon Redshift as well as our relational database service, but you can actually get data out as well. And it allows you to do some consolidation of data and tables through the database migration service. And in terms of sources and targets we support, so on-premise or on relational database service, Oracle, SQL Server, MySQL, MariaDB, Postgres, and Sybase are the supported sources. And the targets, and for our discussion, of course, can be Redshift, but you can actually leverage other targets within our relational database or on databases running on EC2 to be able to seamlessly migrate from your existing platform into Redshift or other options as well. And so from a pricing perspective, essentially you're just paying a fairly low cost for the compute side, and the data transfer into a availability zone is of course free. And so it provides a really compelling story to get started in terms of your migration by leveraging the migration service to load your initial data sets into Redshift. And so beyond just getting the data loaded through database migration service, you also have the constructs in terms of the schema. And so there's a component called AWS Schema Conversion Tool, which allows you to run an assessment of your existing cluster and being able to understand both from a schema as well as PL SQL or other kind of procedural languages and how they might impact your migration to Redshift itself. And so one of my logos, I guess, is not showing up on my slide, but from a Redshift perspective, the Schema Conversion Tool supports Oracle as well as Teradata. And this allows you to understand all the objects and get an assessment report in terms of what percentage of these objects can move into Redshift itself. And if there are any manual interventions in terms of unsupported data types or procedural callouts, you'll at least understand the scope of effort involved in the migration by leveraging the Schema Conversion Tool. So there's a number of resources. I know I kind of quickly covered a bunch of things in terms of best practices and options, but going to our AWS Big Data blog to understand concepts such as micro-batch loading and zero administration data loading for Redshift. But then just simply looking at the Redshift best practices references through designing tables, querying tables, loading data will provide you a great starting point for your migration and take advantage of the full capabilities that Amazon Redshift can deliver. So now that we've kind of gone over some of that information, we thought it'd be great to hear from an actual customer that's gone through migration. So I'll turn it over to David and team to talk about their experience in terms of migrating to Redshift.
Awesome. So I'm David Giffen from TrueCar. Wanted to talk a little bit about how TrueCar sort of leverages Redshift and made our migration out into AWS. So about TrueCar. TrueCar is a digital automotive marketplace. TrueCar provides comprehensive pricing transparency, letting you know what others paid for their cars, helping you get a great deal on your next car. So we enable consumers to engage with TrueCar certified dealers who are committed to providing a superior purchase experience. So I'm David Giffen, the VP of Technology. We have Sharat here with me, the Director of Data, and Blagoy, who's going to give most of the details here in the presentation. So I wanted to talk a little bit about why we decided to move to Amazon Redshift. So let's see. So where we came from, EDW and PDW were basically our enterprise data warehouse. They were constantly running out of disk. All of our ETL was basically in stored procedures within EDW. There was inconsistent naming schemes. We used basically a single machine to process all of our ETL as well as the live reporting. Our live reporting happens on Tableau and MicroStrategy for our visualization, but we constantly had to buy more hardware to add disk to our EDW server. So we're basically racking and stacking disk shelves, trying to actually keep the system running and keep all of the data moving within our data warehouse. So as we looked at AWS, we looked at where we're going to migrate our production databases to, and we looked at MySQL, a couple different options, but we sort of landed on Postgres as sort of the database that we wanted to actually go into. Meanwhile, while this was going on, I asked the data team to take a look at Redshift because Redshift seems like a natural fit for our data warehouse. So the nice thing is that actually provides a common language because Redshift is based on Postgres, and so our production databases as well as our data warehouse databases all end up being in a very common Postgres language. So the nice thing about Redshift is it allows us to scale out to many nodes and really stop purchasing hardware. We can add nodes on demand and and really scale out the cluster. One of the things that I asked the data team to do was to sort of rethink how we were doing all of our ETL. And so we decided to sort of take new approaches on how to get the data into AWS. And so Blagoy is actually going to go into some of the details there.
Hi everyone, so my name is Blagoy Koloferov and I'm part of the data team. It's a pleasure to be part of this webinar. Here's the agenda for the rest of this talk. I'll give you a brief introduction of some of the data we deal with and how we're doing reporting on it. Then I'll give you a high-level architecture of our data processing pipeline and where Redshift fits in that picture. And finally, I'll go over some of the lessons we learned along the way of migrating to Redshift. So obviously, TrueCar is in the automotive space. So that really means that we're dealing with some really interesting data sets. We do have our internal data, such as our clickstream website data and leads. But also we are dealing with inventory data sets, which basically represent the cars that are being sold in the United States. We have sales information, tons of dealer data, and some of that could be kind of tricky because to really extract it, you have to get it from a lot of sources. But when you combine it together, you can get a lot of value from it. And Redshift is essentially the data store where we put everything together. And currently, we are doing analytics and reporting using our BI tools pointing to Redshift. And it's important to note that our strategy with Redshift was to have all of our already transformed and processed data land there to really minimize additional ETL on top of Redshift. So here's the kind of high-level picture of our architecture. We have the data sets on the left that I mentioned earlier, and they're all pushed into our data center, into HDFS, and we're doing this through a couple of ways. We have FTP and other internal mechanisms. And then we have our core data engineering team do all kinds of ETL on top of that data. For some of the most advanced cases, we have MapReduce, but we also have Hive, Pig, and we're scheduling all of that through either Talent or Oozie. And then our data warehouse team is doing some additional staging in Postgres, in AWS, and additional ATL. Now, once we adopted Redshift, here is where it fits. All of the data that we transform lands into HDFS, and then it's very easy to push it into S3. And then from there, we're essentially copying all of the data into our Redshift cluster into different tables. And we have reporting using MicroStrategy, Tableau, and finally we can also do ad hoc. And I hope you can see there is a very clear distinction here with this type of paradigm between data processing and transformation and reporting. We really wanted to separate those two processes because, as David mentioned before, we used to have a lot of processing and reporting on the same SQL server, and that made it really difficult to scale, and we had to support hardware. And now with Amazon Redshift, creating a cluster was extremely easy. So a couple of more details on the schema design of the Redshift cluster we created. We really wanted to keep all of our major data sets in a read-only schema that all of our ad hoc and programmatic reporting would use. And that was good for a couple of reasons. First of all, we avoided having people do additional ETL to do further transformation and do their own defined metrics, as that made it more confusing. And in our automotive space, we have tons of types of definitions of pricing metrics and other stuff. And the benefit of keeping everything in a read-only schema was quite obvious when people were able to easily find the data sets they needed. And when people needed to do some kind of user-created tables, we had separate schemas for that as well. And finally, we really wanted to focus on simplifying things. So we had a very straightforward naming convention for our tables. We had facts, dimensions, and aggregates. And for our aggregates, we had daily, hourly, weekly, and monthly aggregates, so it was very easy for users to find what they need. So I'm gonna jump next on some of the learnings we had as we were migrating to Redshift. So first of all, step number one is to push all of your existing data into Redshift, and Greg went over some of the details there, but for us, we had all of the data processed from MapReduce, Pig, and Hive, and that was available in HDFS. So our use cases went beyond a simple copy command and load. So we built our own Amazon Redshift loading utility that handled not just simple loading, but use cases such as truncate load, where you might want to refresh a static data set and delete it before you copy it. Delete append, which was great for our batch processing. If you have an hourly data set, you ensure that all of the data with a specific timestamp is deleted before you do your batch copy. And finally, the most advanced use case, which is absurd, with Redshift, we didn't want to do individual inserts. So when we had a batch of new data, we were able to pick primary keys from the target table in our loading data set, and we would push our data to a staging table, delete the data from the target table, and do a copy. So the next part is table design considerations. I would like to start with kind of my main learning from working with developers on migrating to Redshift. You really want to make sure that people understand the workings of Redshift and review the best practices that are out there, and there are plenty of resources for that. And what are some of these details? You want to focus on column compression and encodings. In our experience, it's very easy to use the available analyze compression function of Redshift, which will give you some suggestions on how to compress your data, and it really makes a big difference when it comes to space savings and also cost savings. In addition to that, obviously pay attention to sort and distribution keys. You can distribute your tables in a couple of ways. For some smaller tables that have less than 1 million rows, it's totally okay to distribute it across all of your nodes. And finally, if you move to Redshift, as your usage grows, you're going to have more and more users, so it's a good idea to plan for some kind of workload management strategy to ensure that your critical users that programmatically load data have enough bandwidth. Next, I would like to go over some space considerations. When we're pushing data, we're doing it through a copy command, which means your data should be in S3 before it goes into Redshift. And that has a couple of good side benefits for us. We're retaining that data, and it's also available for other tools such as MapReduce, Pig, and Spark. Also, as your tables grow, consider migrating chunks of historical data into other historical tables to reduce the stress on your main data set. An example of that would be, for example, having clickstream, and if you don't need to regularly query more than 6 months of clickstream data, you can just offload some of that into a separate table. And finally, our paradigm with Redshift really meant that we wanted to pre-process the data before it goes there. So we really tried to pre-aggregate everything on as many levels as possible, as that made it very easy for our users to get the data sets they need without additional work. Finally, I would like to wrap it up with some long-term usage tips we learned. As we were moving into Redshift, we wanted to make sure that we have a cluster resize strategy. It is actually very easy to rescale your cluster if you need more space, but when you're doing so, you're going into read-only mode. So if you can't afford having any downtime or if you can't stop the processes that are pushing data, one other way to go about it is to make a bigger cluster from your latest snapshot and later on restore the chunk of data that was loaded while you were creating your new cluster. Also, as Greg mentioned, it makes tons of sense to use reserved on-demand instances. To us, Redshift is the type of data store that you don't need to spin up and down all the time, and it's a long-term storage. And really plan for long-term space growth. It's a really good idea to have plenty of free space in your Redshift cluster. And finally, Vacuuming is quite important for many of our tables. Unfortunately, we can't have all of our data sorted because of the nature of our tables before we push it. So our data warehouse team is scheduling some regular vacuuming, nightly vacuuming on some of our tables. And the system tables that are available in Redshift are really your friends. If you want to monitor or do some kind of alerting on cluster usage, you can also set up some jobs that are giving you monitoring through those tables. Of course, the other option is to use the Redshift UI. And I would like to wrap it up with this pointer to that GitHub repo that our developers have been using. Should you ever have some kind of Redshift specific needs, you should definitely check it out. We from personal experience found plenty of good scripts that handled some of our needs. And with that being said, we can go ahead with some questions.
All right, thank you, Blake. All right, thank you, Greg and the TrueCar team for a great presentation, and also to Zach and Eric for engaging with our audience throughout the presentation. On your screen, you will see 3 live poll questions. Please provide us with your feedback by clicking on the radio button next to your reply for each poll. We do have about 10 minutes left, so please feel free to continue submitting questions, and we will start addressing some of those that have been submitted. We do apologize in advance that we may not be able to get to all of them. And with that, I'll turn it back over to our presenters to start addressing questions.
Okay, all right, so this is Greg. There were a couple of questions I just wanted to talk about. So one question that came up was I was mentioning some of AWS partners in terms of ETL, and the question was, will only those listed in the partner page work with Redshift, or other ETL vendors also work? So I think if you go to aws.amazon.com/redshift/partners, you'll see data integration partners listed. Those are, the ones that we've worked directly with in terms of certifying, and they have native connectors into Redshift. But of course, there's a much larger ecosystem potentially of third-party tool sets, and if those third-party tools can write a file to S3, then the process of implementing copy command to get that final step of loading into Redshift should be fairly straightforward. So my answer to that would be yes. Essentially any tool that can write a file to S3 should be able to integrate with Amazon Redshift. And then there's another question: does the current database migration service and schema conversion tool does not support Netezza to Redshift? Any plans to provide support in this area also? We definitely welcome your feedback in terms of the ways that we can enhance the service, but the two schema conversion tool sources that we support are Oracle and Teradata, and the source being Redshift. And we definitely value your feedback on ways that we can continue to improve. But just because database migration service and/or schema conversion tool does not support Netezza today shouldn't prevent you from moving forward with your evaluation of Redshift. And so we have many customers that have moved from Netezza to Redshift very successfly, and without necessarily the support of the native AWS service, database migration service itself. So I know, David and the TrueCar team, are there any questions that you'd like to address?
We can start one by one. So the first question I see is why HDFS layer was used in TrueCar. TrueCar has been leveraging Hadoop for a couple of years now, so a lot of our processing jobs are pointing to HDFS, so it just made a lot of sense.
Yeah, one thing to note here is that we are in the process of doing a migration, right? So a lot of our current production data actually exists in the data center, and we use Hadoop in the data center as well. So part of the migration is sort of rethinking what the schema looks like in AWS, but then we still have to migrate that data from the data center into those tables in AWS. So anyways, that's part of why we do what we do with HDFS, is really it's where data lands today.
So next question, why not directly ETL to S3? I think that is kind of answered from the previous question. So the other one is, what was the throughput for these loading utilities, specifically Upsert? What was the record volume? I don't have the exact numbers, but I definitely know that we've pushed more than 2 million records using an Upsert, and it was pretty quick. It took, I believe, less than 10 minutes. Next question. For TrueCar, was it EMR to Redshift direct live data flow? It was not.
Can I? So for the previous question, sorry, for the throughput question, the thing is, it also depends on the base, the volume of your base table. So that is what, if you followed Greg's presentation, if you're upserting time series data, try to break it up into multiple small tables. So if you're doing upserts, that would be on a more recent table. So you're not upserting a table which has 200 billion records. So you're only upserting on smaller slices of time series based data. Thank you.
Then we went over that. So what was the DB platform that was used for EDW? Assuming it was not Postgres already, did you leverage data in S3, and what was the experience like?
Yeah, so again, EDW is our current data warehouse or old data warehouse in the data center, and it's based on SQL Server. And then, did you leverage the data S3? Yeah, I mean, basically all the data that we process lands in S3 and then is processed for load into Redshift.
Did you use Talent Community Edition or Enterprise Edition?
We use the Enterprise Edition.
And that's all the questions that we have on the TrueCar side.
Okay, and I don't see any other questions that have been assigned to me either, so I just wanted to thank everyone for joining our webinar today, and thanks to our friends at TrueCar for sharing their lessons learned and their story about their migration to Redshift. And you will get an email with a follow-up to this webinar. If there's any questions, please check out the AWS forums or aws@amazon.com/redshift, and there's great information in terms of getting started, how to leverage our free trial, as well as other customer success stories to help guide your migration journey. And always, reach out to us if there's any other questions, and we look forward to catching up with everyone next time. Thanks, everyone, for joining.
All right, thank you, Greg. I would like to extend a special thank you to our presenters, Greg and the TrueCar team, for their time and a great presentation, and Zach and Eric for answering the audience questions. If you do have any comments on our previous or upcoming webinars or suggestions on the topics you wish AWS to cover in future webinars, please feel free to email aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thank you, everyone, for taking the time to join us today, and enjoy the rest of your day.